Hello everyone and welcome to this CUBE conversation with Cisco today. I'm Christophe Bertrand, Principal Analyst at theCUBE Research, and I'm very happy to welcome Tom Gillis, who is the SVP and GM of the Infrastructure and Security Group at Cisco. Tom, welcome. Great to have you.
Thanks for having me.
So, small job, right?
Yeah.
What do you do every day?
Well, there's a reason why we're combining security and the core infrastructure, and that we see a very interesting conversion, and we can do security in ways that we never could before when it's deeply integrated into the fabric of the network.
And that's exactly what we're going to talk about today. I can also see this confluence of multiple technologies and markets combining even beyond AI and security.
Correct.
And networking.
This architecture is applicable for any application. AI is driving some urgency around it, but applications in general need a more fine-grained, more distributed layer of protection than a traditional hardware-based, perimeter-based approach.
Well, and I would guess that's where smart switches come into play to a large extent. So let's talk about the term, because a lot has been said about it. How do you define what a smart switch is? And then maybe double click on how different is it from a regular switch?
Yeah, sure. It's a significantly different architecture than a traditional switch. So it's not just a marketing nomenclature. A smart switch has two personalities. It has the personality of a network device, which means ultra fast, ultra stable, ultra reliable, and frankly, you don't change it all that often. The security personality has to be deeper levels of inspection, flexibility, and rapid updates. Right? Security stuff gets updated like on a kind of almost continuous basis. And a smart switch brings both of those personalities into a single device. So we can have two different lifecycle management, two different administration capabilities, but one integrated solution. And that's the magic there.
Right, so sort of this duality or twin personality. So what's the role of DPUs, and how do you leverage those, and why is this actually a critical component?
Yeah, this is important. A smart switch is an architecture that brings those two personalities together. It's not about a DPU. It's about bringing a security capability and a network capability into one box. What the DPU does is that it's a hardware accelerator that allows us to achieve data center class throughput for traditional firewall functions. So there can be other versions of a smart switch that would be more appropriate in different parts of the network, like our Catalyst smart switches. They don't have DPUs because they don't need DPUs. But in the data center, you need the very special hardware of a DPU to achieve the throughput rates necessary.
And to what extent do you think this approach has been more successful than a software-only approach? Because there have been conversations about, oh, we can do everything in software these days. Well, we don't need hardware anymore.
And if you know my background, I've spent a long time working on software-based distributed systems. And so those are very, very powerful. What this approach allows us to do is to bring the enforcement points to many, many, many different types of workloads that you couldn't put a software agent into. And it's important also to point out that the smart switch, as powerful as it is a component in Cisco's mesh firewall. So a mesh means it's a distributed system that can live in software, in the host. It can live in a server on a DPU. But we think a particularly interesting and unique form factor is when it lives in the fabric of the network itself and can protect workloads that otherwise can't be protected.
Right, and if you think about this in the context of AI, the promise of AI, and the fact that it's really changing the nature of what networking is to begin with,
yes,
especially with very, very distributed environments, maybe totally independent environments that have to live on their own at the very, very edge, it becomes all the more critical to be able to handle not only the throughput, but the bandwidth, make all of these decisions in terms of security.
Yes.
Let's talk about operational aspects. Why is a smart switch something that changes the game from an operational efficiency perspective for the admin, but also literally for the whole organization? Yeah,
where a smart switch shines is for intercepting and analyzing what we call east-west traffic, which is the traffic between a database and an app server, right? The inner workings of a data center. And east-west traffic is typically 20 to even 100 times greater than what we call north-south, which is coming over the perimeter. So a smart switch is not going to replace a traditional hardware-based firewall on the perimeter, but it's going to bring enforcement into traffic that today is generally not touched. That stuff's moving around, and like you have little to no enforcement on east-west traffic. And so this allows you to employ this enforcement. It's just not practical. Have been customers that have tried to do it with a hardware-based firewall, but it creates these crazy network loops and crazy performance bottlenecks, and it's just not a practical solution. And so this makes east-west traffic enforcement and application protection, actually viable.
Right, and in the context of, let's start connecting the dots, in the context of what we're seeing with AI and the explosion of AI, but more importantly, the fact that we see all of these bad actors leveraging AI to try to penetrate, not only from the outside, but sometimes just staying inside for a bit and then launching an attack. Why is it so critical to have the security layers and capabilities also embedded at the smart switch level?
Yeah, so let's talk about that. Have you noticed there hasn't been any big 0 days in the news, right? We haven't had a Log4j type of,
It's been a while.
It's been a while. And that's not because attackers are lazy or because they've stopped attacking. It's because what they've realized is a 0 day is really hard to do. And with these AI tools, as you were suggesting, you can automate attacks against existing known vulnerabilities. So you don't have to go discover an unknown vulnerability. Just when they announce a new vulnerability, AI can assist the creation of an attack that is going to exploit that vulnerability. And so it used to be that we would see, there would be weeks would go by before we'd see activity around an announced vulnerability. Now it's minutes. And for most customers, it is simply not reasonable to patch hundreds or thousands of applications in minutes. That's just not a reasonable thing. So one of the unique capabilities of this distributed architecture we have with the smart switch is the ability to apply a compensating control to that application. When a vulnerability is announced, we create a shield which will protect and prevent the exploitation of that vulnerability. And we can deploy that in either a fully autonomous or a semi-autonomous manner. And you really couldn't do that without the granular distributed approach that we have with the hybrid mesh firewall and the smart switch.
Yes, and arguably now is the right time to be doing this, right? Not only because we're seeing all of these attacks and the acceleration of attacks, but now there are AI-enabled attacks.
Correct.
So the demultiplication, the operational, the industrialization of attacks has become absolutely ridiculous.
Yes.
So you think about pushing now, if I'm the viewer, I'm a networking professional, I'm an IT professional, maybe I work in cyber resiliency. Tell me again, why now? Why pushing security down the fabric? Isn't there a risk of complexity maybe?
Well, it's the opposite, actually. It dramatically reduces complexity. So let's just do some simple math. If you're using a hardware firewall to do zone firewalling, like many customers will put hardware firewalls in between VLAN segments, for example. For high availability, you use 2 switches, 2 hardware firewalls, 2 more switches. That's 6 boxes. With a smart switch, it's 2 boxes. Okay, so we can reduce the number of boxes, reduce the number of hops. And with an integrated management solution, we make it much, much, much easier to use this. I've said it's 2 personalities, but it has a unified management framework. And so the network team can manage the network stuff, the security team can manage the security stuff, but they live in the same device. And so traffic routing is all the responsibility of the network, of sending the traffic back and forth into the security domain.
So I think this is very important what you just said, because it sounds to me like the sort of traditional approach to networking has changed. I mean, there's no question about that.
Yes.
But in the context of this AI-enabled actors, bad actors, isn't the role of the networking team fundamentally changing? And what do you see in terms of what they need to do, how they need to plan, more importantly, and how they fit in the broader picture?
Yeah, so what we're showing is that we can deliver a much better security outcome by integrating security and network together. The old days of, there's a firewall team and a network team, and they open tickets to talk to each other, like those days are gone now, right? And so by bringing those together, we can deliver a much better security outcome. And the skills, the role of the networking professional is changing. It's changing to address more of these security concerns. There's another big shift coming, which is this movement towards AI infrastructure to power all the AI applications.
Right.
And this is a little more complicated, so let's dive into this a little bit. With traditional Kubernetes-based apps or VM-based apps, you're running on a CPU, which is a sequential processor, right? So you're executing instructions one at a time. With an AI application, you're using a GPU, which is a parallel processor, and they are massively parallel. Right. And so each time Moore's law clicks, our friends at NVIDIA are putting more processing elements on each chip, and each processing element is getting faster. But these AI applications will span more than one GPU. And so as the GPUs talk to each other, the data rates that they talk to each other at are like an order of magnitude more than a traditional data center network. So if you were proud of like, hey, I've got my 100 gig network in place, like I'm good to go, guess what? We're pushing 800 gigs when we're doing GPU to GPU, and that's not enough, right? The cutting edge customers that we work with, these very, very large AI infrastructure providers, they're looking for 1.6T, they're looking for 3.2 terabits, right? So the demand for network bandwidth on what we call the back-end network, which is the network that services those GPUs, it is really insatiable. And I think Cisco's unique value proposition is that we don't treat the back-end network like some separate thing, right? Whether you're a front-end network or a back-end network, the Nexus switch with all the Nexus management tools can power both of those networks. And because of the programmability of our Silicon One architecture, we know, oh, this is a back-end mode. We run very different algorithms for how we manage that traffic at those really high data rates, and then we would in a front-end network.
Yeah, which has also the benefit of making the investment in the technology a pretty long term and highly high return investment because of the flexibility.
Well, we've seen historically over and over again when a new, let's call it specialized networking protocol comes out, ultimately Ethernet subsumes it, right? Because for this reason you just said, customers don't want to manage two networks. Right. You want to manage one network that can work in two different modes. And this has really been the focus of our partnership with NVIDIA, is simplifying and streamlining networking operations for AI-based workloads, as well as for Kubernetes and VM-based workloads.
So Tom, we've talked about east, west, north, south, all the cardinal points, but yes. What's at the center? What about your switch? How do you protect it?
Yeah, well, so we spent a lot of time thinking about how we can shield the vulnerabilities of an application. Cisco has an application. It's called the Network Operating System. And if you're reading the news, if you've heard of things like Volt Typhoon and Salt Typhoon, what we're seeing are very sophisticated nation-state attackers that are targeting infrastructure. Not just Cisco infrastructure, but we're the largest infrastructure provider, networking infrastructure, networking, firewalls, load balancers. And so as opposed to simply making a kind of incremental effort of like, hey, let's try to put less bugs in the software, what we've done is a pretty dramatic step, which said, we just recognize software is going to have bugs. Yes, we're going to minimize the number of bugs that are in there, but when there is an issue that we find, we have the ability to apply those same compensating controls using the same mechanisms based on our runtime security agent called Tetragon. We've embedded that into Cisco switches. So networking folks, listen to me. We have the ability to apply a compensating control, which is not a patch, I want to point out, right? It doesn't obviate the need to patch, but it's a temporary fix that can protect your switch, and you can apply that without rebooting the switch. So no change control window, no downtime, no emergency upgrade. You can now upgrade in an orderly fashion during normal scheduled maintenance windows. And we think this is really a leap forward in terms of the integrity of the infrastructure, but also the operational simplicity that Cisco brings to very large-scale networks.
Let's go back to the cardinal points for a second. Does this concept of east, west, and north, south still apply in the age of AI?
Yeah, it certainly does. And for AI-based applications, you're not just clicking on a link. You're interacting with a prompt. And so the amount of data that's coming through on what we call the front end of the application, it's like an order of magnitude larger. And you want to be able to provide protections for that in line in real time. And so a traditional hardware-based approach to firewalling is going to struggle with that. And so what Cisco has done is we have worked with our partner NVIDIA to be able to put security policies directly into the NIC and run them at line rate. So the Cisco firewall is a mesh, and a mesh means it can run in a hardware appliance that you know and love today, in that host that we talked about with eBPF in Linux and Windows, but it can also run in one of these Bluefield NICs. And so you have multiple different enforcement points for the appropriate insertion into the network.
One of the questions I have for you, it just came up. We've talked a lot about AI, and how do you leverage AI? If I'm, again, a networking professional, what can I expect? I mean, of course you have great, user interfaces, but things are changing. I mean, are you thinking about, leveraging more AI? How do you leverage it? Voice, maybe even. What are the tools that you're going to
It's fairly transformative from a management standpoint. So let's pick an interesting example, which is access control. So a buddy of mine was a network administrator, and he says, the thing I hate is changing the access control tables, like the ACLs and stuff, because you have this gigantic complex rule set, and then you have to make a change. And he said, every time I make a change, I'm afraid that I'm going to inadvertently forward the CEO's email to everybody, right? So it can be a scary proposition. So with our new secure access, which is, again, an example of security meeting networking, when you go to make an access control policy change, before you push that change, the little endpoint that we use for our Zero Trust client has Cisco's Thousand Eyes capabilities built into it. That's a synthetic traffic generator. And so it allows us to simulate the policy and say, is this doing what you expect it to do?
Right.
So really, and this is shipping. This has actually been shipping for more than a year now. AI management capabilities, I believe, is going to allow us to reach a point where network outages due to either misunderstanding of a configuration or misconfiguration, we're going to drive that to zero. And as you know, the vast majority of network outages are due to misconfiguration.
Yes, exactly. Now we hear those on a regular basis in the news.
Yes,
that's for sure.
Yep, but it's almost always human error, right? And so, I mean, every now and then an ASIC will fail, but we usually design around that. Having the ability to manage policy in an automated fashion, the AI tool sets that Cisco is developing really do that. And what makes us, I think, unique is the end-to-end view. We don't just look at our little link or one hop. We look across all the hops and make sure that this thing is working the way you think it's supposed to work.
Right. I think that simulation or sort of automatic testing piece is absolutely critical.
Yeah, it's really cool.
Also, it can help in the case, when things go wrong and they can happen, you can quickly rebuild or rebuild faster.
Right. We call it mean time to innocence. Right. So because when anything goes wrong, who's to blame?
Right.
There's the network, and then we realize, actually not the network at all, right? It's a cable cut or it's a data center outage or what have you. Yeah.
So you mentioned Zero Trust. Let's talk about that because it's obviously a big enterprise initiative typically, and Zero Trust has many meanings depending on who you talk to in the infrastructure.
Correct.
So what is your not interpretation, but really your deployment of Zero Trust in the architecture and in the technology, and also as a company?
Yeah, sure. So the principle of Zero Trust is actually quite simple. Like it's least privileged access, which means I'm only allowed to get to the resources I need to do my job and nothing else. Right? So salespeople can get to sales apps, IT people can get to IT apps, but you don't want salespeople in the IT apps. Simple concept. It can get really complicated to deploy that. And there's two places where we deploy it. We think about users coming in to access applications, and that's where things like Cisco Secure Access do a very, very good job of that automation of the policy formulation and deployment. But I think a more interesting part of Zero Trust is when we think, once someone clicks on that web server, all of those back-end operations, the east-west traffic that we talked about earlier in a data center, those should have Zero Trust principles too. Meaning, if I'm a database and I'm sitting way, way, way back, many, many hops back behind the web server, and I've got SSH or RDP access capability, that web server should never SSH into the database, ever, right? So if you apply those least privileged Zero Trust principles, you'd say, oh, that should never happen. The web server doesn't need to get there. Let's turn off and block that connection. And this is microsegmentation. right? That is a really important and powerful zero trust capability. And it's really hard to do that because it's difficult to understand the various services that make up the application. It's coming full circle. That hybrid mesh firewall that I talked about, the ability to have something in the host or in the network that can understand this is a database, this is a web server, right? This is the app server, map out the topology of the application, and then automatically apply policy around it to enforce these zero trust principles in the data center as well as for users accessing applications.
Right, and this goes beyond just security because we're immediately here talking about governance and potentially compliance.
Correct.
Accessing data
Correct.
be...
PCI data should only be accessed in certain ways. We need to make sure we're compliant, right? So these segmentation capabilities are super, super important for customers.
Right, yet another good reason to think about smart switches.
Yes.
Here's another one.
Yes.
Okay, you talked about users.
Yes.
But soon, and now we're starting to talk about agents. And some people said, well, you should treat, agents like they're your employees, which means, well, they have certain access, they have certain things they can do, you have to monitor them, etc. So as we see this proliferation of agents, and it's going to accelerate, what do you see as some of the main challenges that end users, meaning the professionals dealing with a network, will have to handle, and how do you help?
Yeah, it's a huge problem. And it's a problem that's moving with a speed that reminds me of the onset of spam. Remember when spam, it just kind of came out of nowhere and all of a sudden was plugging up everybody's inbox. You couldn't get your job done. It was crazy, right? I was one of the founders of Ironport when we built spam filters, right? So I remember that time vividly. This, I think, is a similar problem. And here's the way I describe it. We talked about least privileged access and the access control that we put around humans. Humans have generally pretty broad access and pretty long-lasting credentials, right? So you have a password that's good for 6 months or a year. We can use multi-factor authentication and techniques to make that tighter, but for the most part, like once you log into the network, you can hit hundreds, sometimes even 1,000 applications, okay? Now, on the other end of the spectrum, we have machines. Let's think about a printer or a telephone. Cisco has very strong capabilities to identify and fingerprint, this is a printer. We'll put tags on that, right? And on that network traffic. And then we can put those least privileged policies in place. And the printer only talks to the print manager, nothing else. Very, very restricted, narrow access. So all of a sudden you got AI agents which have the broad access of a human, but the common sense of a printer. Right? And that is a giant, giant problem. And so what we, the industry, need to do is we need to put in ephemeral, session-based controls that allow an agent to do what it's want. Because we like agents. Have you used these things? They're unbelievable, right? It's, I can't believe the power. I use the OpenAI stuff. It's just so effective. So it's going to take place in the workplace whether we like it or not, right? It's going to be processing expense reports. It's going to be helping us with tasks. And it's going to have user credentials. So first thing is we need to be able to tell the difference between a user and an agent, which we can. And then the second thing is we need to put more transient, ephemeral, finer grained controls around those agents so they don't go running wildly amok. And that's work that we're doing now, and I'd say we can complete that reasonably well. The third thing is harder and I think interesting. So let's imagine, Christophe, you're using an agent to process expense reports, okay? You want to let that agent have access to your calendar, so it knows where you were, your travel system like Concur, and your credit card to process the expenses. So you want the agent to access your credit card, but you don't want the agent to buy a Porsche, right? And if you use my credit card, it would have to be a used Porsche, but still, like we don't want the agent to buy a Porsche. And so here, once we've identified the agent and we've done the access control policies that I talked about, the session-based access control, we're using AI to supervise the AI. So we have a technology we call AI defense, where we build models that look at what we think is normal behavior, and then we can use the AI that we build, our models, to supervise your models and say, this agent is doing something that we think is outside the bounds of normal. Now, it's a very, very hard problem to solve, and by definition, I'm gonna say it's imperfect, but it's it's way better than nothing, which is what most customers are gonna have. So, yeah, these AI agents are gonna change the way networks work, the way users and machines access the resources they need. And this is true on the north-south side, but also within the data center, right? When those agents are talking to those other APIs and doing that more east-west type of compute, we need to apply those same principles.
Right, and I see that there is another tie here with, governance and compliance. If you get this done right, you're probably covering a lot of your bases for, illegal access, literally.
Oh, totally.
And of course, bad decisions stemming from all of these contextual issues.
I will argue the illegal access is easier problem to solve because when it involves legality, there's a black and white, right? If this is legal, this is not. The harder one is the judgment of should the agent buy a Porsche or not, right? And what if it says I'm not going to buy a Porsche, I'm going to buy sort of a Lamborghini. Well, that's wasn't in the rules, we don't know. So you need to be able to apply reasoning to enforce more effective security policies.
I have suspicion car dealers do not like you right now. Look, let's talk about looking ahead a little bit. What do you see as the future of networking in this? I would say the next phase of AI. We could call it this intelligence revolution that we're starting to see.
Yeah. Well, again, if you haven't been banging around on ChatGPT, get out there and do it. At this point, I am convinced that ChatGPT is both smarter and funnier than most of my friends. So wow, the machinery that powers that is unbelievable. It's the scale at which these things are being built out are like nothing I've ever seen before. You and I were talking about this before the camera. These are composable systems.
Right.
Now, I'm a computer science nerd, and I've been waiting. The idea of composable systems is so cool and so powerful and so interesting. But the idea is you've got this big lump of hardware, and then you can partition some chunk of that to do the work of processing these AI applications and make them even smarter than my friends. And so what's the common denominator of all this? It's the network. The network is becoming the substrate. So think about the network in an AI world. It plays the role that the PCI bus played in a VM in a Kubernetes world, right? It strings together the pieces of a computer, but this computer could have tens of thousands of processing elements that are coherent or semi-coherent, right? That we're pulling all together in one giant computer.
Yeah. Tom, we've covered a lot of ground.
Yep.
Thank you so much for taking the time, and it was great to have you.
Always a pleasure to be here. Thanks.
And to our viewers, thank you very much for your time. I'm Christophe Bertrand, Principal Analyst with theCUBE Research. See you on the next one. And I think we're just at 26, 27 minutes.